In this session, we're going to be using machine learning technology to identify predictive traits in big data. Specifically, we're going to look at how Calexus genetic algorithm technology can very rapidly provide you with a model that will allow you to classify members of large data sets into those who are much more likely and those who are much less likely to register a particular outcome that you're interested in. For the purposes of the presentation, we're going to be using a publicly available data set that pertains to Medicare recipients. And we're going to be predicting an outcome that all of us are interested in. We're actually going to be predicting life and death based on the answers that are given to the Medicare survey. Every 2 years, Medicare surveys about 60,000 recipients and asks them a bunch of general health questions, like, for instance, have you had cancer? Have you had chest pain? Have you had diabetes? Because the population is elderly, unfortunately, the next time, 2 years later, when they come around and do the survey again, about, over under my mouse here, you can see from some of the statistics of the data set, about 7.5% of the survey respondents are no longer with us. And what we're going to do in this presentation is see if we can identify the traits based on the answers that were given in the first survey that make it more or less likely that a particular Medicare recipient will have still been around at the time of the second survey. So I'm going to start the model here, and we're going to have a look at the process in action. As the name genetic algorithm suggests, the process is one of continuous improvement. The computer is actually going to build successive generations of models, each generation containing 125 different models. It's going to try each of those models against the data set to see which is the most predictive, and it's going to keep the best parts of each model and pass that information down to the next generation so that the model will continuously improve. And you can see the results of that process here on my screen. The degree of fit of the model in terms of predicting who are the most likely people to have lived or died based on the answer that they gave us in the survey is represented by the blue line, which is continuously going up, representing the fact that the models from successive generations are improving each time. So let's take a look now at a copy of the model that's been running for 1,100 generations, meaning that about almost 150,000 different models have been tried. You can see from the fact that the blue line has flattened out that almost all of the predictive information has been squeezed out of the data set now, and there isn't a lot of improvement going on with successive generations. So let's take a look at the outcomes, or the results of the model. We've broken the data set down into deciles of about 6,000 people each and scored all of the people in the survey based on the answers that they gave to the various questions. And you can see that over here we've identified 1/10 of the population who are actually 4 times more likely to have died than the norm. And over here we've classified people who are only about 1/6 as likely to have died as the norm. The model's interactive in that it lets us see the variables that have contributed to the prediction. The ones in yellow here are the ones that have entered into the model, and we can actually dig down a little bit further and see what is contributing to the prediction. So it's not too surprising, for instance, that somebody who's had angina might be more likely to succumb. We might be interested in seeing what the outcome of this question here about whether the recipients are able to walk a mile was. So it looks on this particular question as though there are 3 possible answers, 1, 2, or 3, and in the 35% of the people circled box number 1, presumably meaning that they are not able to walk a mile, and 13% of them died compared to the average of 7%. On the other end of the scale here, about the same number of people, 35% circled box 3, meaning yes, they could walk a mile no problem, and only 3% of that population died by the time the next survey came around. So obviously being able to walk a mile is a significant predictor, and that would be included in the model. So there it is. In a very short period of time, we've been able to build a model which is successful in classifying people as to their likelihood of survival based on answers that they've given on a general health survey. The same technology can be readily applied to identify the characteristics of fraudulent transactions for financial institutions, or for instance to identify for advertisers people who are more or less likely to respond to an ad that's shown to them on the internet or on TV. We hope you've enjoyed the presentation. If you would like to see the technology applied to your data, then that is certainly something that we can arrange very easily, and you can contact us either email at info@calexussolutions.com or by phone 603-232-3558. Thanks for your attention. Bye for now.